Some basic formulas. We know 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 by 2. And 1 square plus 2 square plus etc. plus n square is equal to n into n plus 1 by into 2n plus 1 by 6. 1 cube plus 2 cube plus etc. plus n cube is equal to n into n plus 1 by 2 the whole square. Then arithmetic progression is AP. The series A plus D, A plus 2D plus etc. is in AP, where D is the common difference and A is the first term, right? These are all the basic ideas, basic definition. Sum of first n terms of an AP is Sn is equal to n by 2, 2A plus n minus 1 into D. That is Sn is equal to n by 2 first term plus last term. Geometric progression GP AR square etc. A r power n minus 1. R is the common ratio, A is the first term. So this is GP. Sum of first n terms Sn, which is equal to A 1 minus r power n by 1 minus n if r is less than 1. If r is greater than 1, the formula is A into r power n minus 1 by r minus 1. So for infinite series GP, a summation is equal to A by r minus 1. R is greater than 1. So summation to infinite series of GP, right, is equal to A by 1 minus r if r is less than 1. We'll see the problem. Find the inverse Z transformation of Z square by Z minus A into Z minus B. Or evaluate Z inverse of Z square by Z minus A into Z minus B. We know Z of A power n, which is equal to Z by Z minus A, right? That means Z inverse of Z by Z minus A is equal to A power n. Now Z inverse of Z square by Z minus A into Z minus B can be written as, so I am splitting Z square into 2 Z into Z. Z inverse of Z by Z minus A into Z by Z minus B. We know Z inverse of f of G into G of, f of Z into G of Z, which is equal to Z inverse of f of Z convolution Z inverse of G of Z. From that note, right, from the convolution there. So Z inverse of Z by Z minus A convolution Z inverse of Z by Z minus B. So from the formula, so this is nothing but first term is nothing but A power n convolution B power n. So convolution of A power n and B power n. So A power n is a function f of n and B power n is a function g of n. It can be written as f of k into g of n minus k. So instead of f and g, you are having a and b. So which is equal to summation k is equal to 0 to n a power k f of k, right, a power k into g of n minus k. So it is b power n minus k, right? Therefore that is equal to summation k is equal to 0 to n a power k splitting the power of b power n into b power minus k. So taking b power n outside, because the summation is from k to k, starting from k equal to 0 to n over k only. So b power n is a constant with respect to the summation. So you are taking outside from the summation, right? B power n summation k is equal to 0 to n a power k b power minus k. That is equal to b power n k is equal to 0 to n a power k b power minus k can be written as 1 by b power k. That is equal to grouping. So is equal to b power n summation k is equal to 0 to n a by b whole power k. Now applying k values, so b power n into first 0, k is equal to 0, a by b power 0 1 plus a by b plus a by b square plus etc. nth term a by b power n. So this is a GP, right, geometric progression, right, AR square like that. So here b power n, a is first term 1 into a by b second term, a into r, right, A into 1 by A by B. A into R, A is equal to 1. 1 into A by B, second term. Then AR into R, third term, AR square. So A by B into A by B. That is common ratio is A by B, right? First term is A. So summation. So nth term, so summation, right, of a GP, right? So A by B whole power n plus 1 minus 1 by A by B minus 1, right? Sum of GP, R power n minus 1 minus R by R minus 1. Here R is equal to A by B. So B power n, splitting the powers to the numerator and denominator, A power n plus 1 by B power n plus 1 minus 1 by A by B minus 1. Taking LCM on numerator and denominator, B power n into numerator LCM, B power n plus 1. A power n plus 1 minus B power n plus 1 by B power n plus 1. Denominator LCM B, A minus B by B. So B power n into, so A power n plus 1 minus B power n plus 1 by B power n plus 1. And the denominator function term can be written as reciprocal, into reciprocal, right? Because we know 1 by A by B is equal to 1 into B by A. Similarly, see, the denominator term can be written as B by A minus B. So B power n plus 1, A power n plus 1 minus B power n plus 1, because we are taking that B outside, because A in the numerator A power n plus 1 minus B power n plus 1 into B, right? So we are taking that B outside, so B power n into B, so B power n plus 1, right? So numerator A power n plus 1 minus B power n plus 1, the denominator B power n plus 1 into A minus B. So we are taking B power n plus 1 in the denominator outside. So B power n plus 1 by B power n plus 1. A power n plus 1 minus B power n plus 1 by A minus B. So B power n plus 1 and B power n plus 1 in the denominator get cancelled. So you will get A power n plus 1 minus B power n plus 1 by A minus B, which is the inverse transformation. This is the general problem, right? Instead of A, you can replace any number. Instead of B, you can replace any number. So you will get so many problems. Z square by Z minus 2, Z minus 3. Immediately, you will get the answer. So this is like a standard formula. Z inverse of Z square by Z minus A to Z minus